Alright guys, today we're going to be talking about polynomial and behavior. So this is a pretty straightforward topic. It's not too difficult. However, in the beginning you're going to most likely going to need this table, okay, in order to identify the end behavior of a polynomial. So let's get right into this. We have this table and let's just kind of go through it and then we'll do some real examples. Alright. So in this column right here, it says p of x has. Now p of x, we're just talking about any polynomial function. All right. So it says if the polynomial function has a leading coefficient greater than 0, then we're going to use this top row here. All right, and then we determine if it has an odd or an even degree. And that will tell us the end behavior. It'll either be this type of graph or this type of graph. All right. Or vice versa, okay? If the polynomial function has a leading coefficient that is less than 0, then we're going to use this bottom row, and then we just determine if it has an even or an odd degree, okay? And if we can then determine what that graph will look like. Okay, so let's go into a couple of problems, and then this will hopefully make a little more sense. All right, so here is our first example. And we have a function, and it says negative x squared plus 5x plus 6. And they want us to determine the end behavior. Okay, so the first thing we need to do is determine what our leading coefficient is. Now remember, your leading coefficient is going to be the term with the highest degree. So again, this is a term, this is a term, and this is a term. Well, which one has the highest degree? Well, it's going to be this one right here. And our coefficient associated with this term is going to be -1. So I'm going to go ahead and write that down, that our a value is -1, or our leading coefficient is -1. So we go to our table and it says if a is greater than 0, then we use this row. So it can't be this row. So a is less than 0, we're using this row. And then we just determine, is it an even or odd degree? Well, it looks like we have an even degree here. So we're using this graph right here. And again, this just says as x approaches, okay, positive infinity, the function will approach negative infinity, okay? And as x approaches negative infinity, the function approaches negative infinity, okay? Let's try another one. So here we are given another function, all right, and we need to determine the leading coefficient. Alright, so same thing, it's going to be the term with the highest degree. So in this case, we're looking at this guy right here. Alright, and so that means my leading coefficient is going to be -4. So my a value is going to be -4. Well, knowing that, we're going to go ahead and use our table now. So the leading coefficient is less than 0, yes. And then we just determine, is it an even or odd degree? Well, in this case, it's going to be odd. So our graph will have an end behavior such as this one. And again, just to read it, as x approaches positive infinity, the function will approach negative infinity. And as x approaches negative infinity, the function will approach positive infinity. All right, let's try one more example. So here is our third and final example. And now be careful with this one because this polynomial is not written in standard form. Okay, so if you want, you can go ahead and write it in standard form to keep things consistent. You don't have to, but we will for this problem. So I'm just going to write this in standard form. So going from highest degree to lowest, we're going to have 2x to the third power plus 5x minus 5. So now we are in standard form. And what we want to do is determine our leading coefficient. So again, that's going to be the term with the highest degree, which is going to be right here. So our a value is 2. So let's go to the table. Our leading coefficient, a, is greater than 0. Yes, it is. Now, is it an even or odd degree? Well, in this case, it's going to be odd. So our end behavior is going to be a representation of this graph. And again, we'll just read it. As x approaches infinity, the function also approaches infinity. Okay? And as x approaches negative infinity, the function approaches negative infinity. Okay? And so that is polynomial and behavior. Right? So in the beginning, you're most likely going to need to use this table, but as you become more familiar with end behavior, this is something you will probably memorize.